please open to page 298 in your student journal. Today we're going to be working on section 9.5. We're going to continue solving quadratic equations. Remember, quadratic equation means the highest exponent of the variable is a 2. So far we've solved quadratic equations by using square roots and completing the square. Today we're going to use what's called the quadratic formula. The quadratic formula is listed here on page 298. In order to use the quadratic formula, we need to have our quadratic equation in standard form. I know standard form is a phrase we haven't used in a little while, so let's just take a little minute to refresh. If we have standard form, that means our terms need to be in order according to highest exponent to lowest exponent. So that means our x squared term will be listed first, our x to the first power second, and our constant, or that number without a variable, will be last. In order to use the quadratic formula, our equation has to be set equal to 0. I know that's a little bit different than when we were completing the square, but now we have to make sure that our equation is equal to 0. If we take a look at the quadratic formula, we see we have some a's, b's, and c's that we have to substitute in for. We get the a's, b's, and c's from the coefficients of our quadratic equation. The a value is the coefficient of the x squared term. Or in other words, the number in front of x squared. Now it could be x, it might be an m squared or a p or a q, it could be any variable. We typically see x. The piece I want to stress here though is it's the number in front of x squared. Now we had to use a back when we were graphing, and we used the little formula x equals negative b over 2a to help us find our axis of symmetry in our vertex. That a value is still the same. We find it in the same place. Keep in mind it is the number. If I just have an x squared, that means my a value will be 1. We don't want to try to substitute x or x squared into our formula. Things will get pretty ugly pretty fast. So again, it's the number. The b value we should be very familiar with. Not only did we have to use the b value when we were graphing to help us find axis of symmetry and vertex, but we also had to find our b value when completing the square. That was one of our very first steps. We had to divide b by 2. b again, though, is the number in front of x, or whatever the variable happens to be. It's the coefficient of x. And again, I do want to stress, it is a number. If there's no number there, if it's just an x, remember, our b value will be 1. Last but not least, we have our c. C stands for constant. If you want to make a little note here, that means it's just a number without a variable. So it's just a plain old number. Now, before we dig in and really start using this quadratic formula, I want to take just a minute and highlight a special piece of that formula. The special piece of that formula that I want to highlight is called the discriminant. The discriminant is b squared minus 4ac. Now, I know you're looking at that formula and you're thinking, Miss Galley, that formula looks like quite a bit for me to handle. And now you're giving me something else to look at. This formula is not something extra. This little formula for the discriminant is actually the same expression that's underneath that square root in the quadratic formula. So finding the discriminant is not going to create any extra work for you. It can create less work for you, actually, as we'll see in just a minute. When we go through and actually calculate our discriminant, there's three different possibilities. We could end up with a positive number, we could end up with 0, or we could end up with a negative number. So let's take a look at those three possibilities. The first possibility is when our discriminant is larger than 0, or in other words, when our discriminant is positive. Now remember, the discriminant is underneath that square root. So if we're going to take the square root of a positive number, that's when we will have two solutions. We had to use the plus minus. So if our discriminant's positive, we're going to have two real solutions. And graphically, let's link this back to our graph. I know we haven't graphed in a little while, but if there's two solutions, those are the same as your two x-intercepts. So if we find two solutions, that means we also have two x-intercepts on our graph. Our second option with the discriminant is that it could equal 0. So if our discriminant equals 0, when we were solving, if we take the square root of 0, 0 is just 0. We can't have a plus minus there. So when we had to take the square root of 0 when solving, we just ended up with one real solution. And if we connect that back to our graph, it means we're only going to have one x-intercept. So only one place on the graph where it crosses the x-axis. Our third and final option with the discriminant is that it's less than 0, or in other words, our discriminant's negative. Now when we think back to all the solving we've been doing involving square roots, whenever we try to take the square root of a negative, we'd put it in our calculator and we'd get an error. Remember, the square root of a negative is not a real solution. So if we try to take the square root of a negative, we're going to have no real solutions. And if we were to graph it, that would mean we would have no x-intercepts. So if we link this back again to our graphing, instead of factoring to get our x-intercepts, we could also use the quadratic formula to get our x-intercepts. So now that we've explored, we've just introduced the quadratic formula, we've seen it, we've picked out how to get A, B, and C, and we've talked about the three cases that could happen with the discriminant, let's go ahead and try this out. Let's go ahead and turn to page 299, and let's try out question 1. And question 1 says, solve the equation using the quadratic formula, round your solutions to the nearest tenth if necessary. What I want to start off with, first of all, is making sure our equation is in standard form. We have my x squared term first, x to the first power is next, and then my constant, my c value, is last. Then I also have to check to make sure, is my equation equal to 0? And yes, it is. After I make sure I have standard form, I want to pick out my a, my b, and my c. The a value is in front of x squared, so we have to be careful here. I can't put x squared for a. There's really a 1 in front of it. Remember, a, b, and c have to all be numbers. My b value is in front of the x. In this case is a -10. My c value then is that constant is 16. Now before we dig in totally to the quadratic formula, I want to start off by finding the discriminant. Remember, the discriminant, it's right on the page next to this, on page 298. The discriminant, we need to do b squared minus 4 times a times c. Be very careful when you're entering this into your calculator. We've seen a lot of times it's really gotten us when we have a negative that we need to square. When I square a negative, the result is positive. So I end up with a positive 100. And one small little thing here that helps, I always see helps students make less mistakes. Instead of doing minus 4, I tell them to change it to plus and negative 4. So now they see it's negative 4 times 1 times 16, which comes out to be negative 64. So our discriminant is going to equal 36. Now what that discriminant can tell us is two different things. The discriminant is positive, so that means we're going to have two real solutions, and graphically it means we would have two x-intercepts. So after we solve using the quadratic formula, we could use those solutions to graph our x-intercepts. So now that we found the discriminant, we know that we're going to have two solutions that we need to look for when using the quadratic formula. Now I know right now you might still be seeing this discriminant as something extra. So let's go ahead and use the quadratic formula and find those two solutions. The quadratic formula again is right next to this page on page 298. The first part of the quadratic formula I see is negative b. There's the negative sign for the formula, then here's the negative sign that goes with b. Plus or minus the square root, and now we see the b squared minus 4ac. That's the discriminant. We already found it. So go ahead and just put 36 there. That is my discriminant. Go ahead and just put 36. All divided by 2 times a. We have a negative 10 that becomes positive 10. Plus or minus the square root of 36 is 6. All divided by 2 times 1 is 2. Now we have to go ahead and simplify this expression. And we see that plus or minus is there. We've been working with that. What this means is I need to do 10 plus 6 divided by 2. And I also need to do 10 minus 6 divided by 2. I need that plus minus case, just like when we were solving using square roots. 10 plus 6 is 16. 16 divided by 2 is 8. 10 minus 6 is 4. 4 divided by 2 is 2. There's our two solutions. If we wanted to graph this, those would be our two x-intercepts also. Let's go ahead and try out one more of these. Let's take a look at number 4. Number 4, I want to find all the same pieces, but first of all I have to check to make sure that I have standard form. If I look at number 4, I have the x squared term listed first, I have the x term listed next, I don't have a constant there, and my equation doesn't equal 0. So I have to fix that. In order to get my equation equals 0, I have to move the negative 13. I do that by adding 13 to both sides. The 13 does not have a variable with it, so I can't combine it with the x squared or the 6x. I just have to put it on the end. Now that my equation is in standard form, it's set equal to 0. Now I can go ahead and pick out my A, my B, and my C. My A value, once again, is just a 1. My B value is 6. My C value is 13. I do want to find the discriminant. I'm just going to label it a shortcut, DIS. It's B squared minus 4 times A times C. Again, I often see a lot of mistakes with the minus 4. I really recommend making it plus and negative. 6 squared is 36. Plus, we have negative 4 times 1 times 13. We get negative 52. 36 plus negative 52, we end up with a negative 16 for our discriminant. Since our discriminant is negative, that means we have no real solutions. And if we were going to graph this, it means that our graph would not cross the x-axis. It doesn't mean we can't graph it, it just means there's not going to be any x-intercepts. So our parabola, that U-shaped graph we've been working with, would not touch or cross the x-axis at all. It doesn't mean we can't graph it, it just means there's no x-intercepts. Now I know you might be thinking, okay, Miss Galley, so let's go ahead and move on and do that quadratic formula. Well, if we come up with no real solutions, we don't have to do the quadratic formula. So here's where the discriminant can save you some time. I'm finished at this point. Now, for those of you that aren't believing me that we're finished, I'm going to go ahead and substitute into the quadratic formula. So let's go negative b plus or minus the square root, and this is just my discriminant. So my negative 16 goes in there, divided by 2 times a. Now we can actually see we're trying to take the square root of a negative, and we can't. Cannot find the square root of a negative. We couldn't do that when we were solving using square roots or when we were completing the square. Now, along with this, though, the idea of not being able to find the square root of a negative, that links us back to this idea of real solutions. I know some of you are probably wondering, why are we writing 2 real solutions or no real solutions? Well, if and when you take Algebra 2, you will learn about a set of numbers called the imaginary numbers. The imaginary numbers help us find the square root of a negative. But for our purposes right now, we work with the set of real numbers, and there's not a real number I can use to find the square root of a negative. So we've seen an example where we've had 2 real solutions. We've now seen an example where we didn't have any real solutions. Let's try out one more. I know I said one more the last time, but let's go ahead and turn to page 300. And I want to look at question number 9. We're not going to do 8 or 10, so if you want to use that space for 9 as well, you can. My equation this time, I do have standard form, x squared, my x, and then my constant, and it equals 0. My a is 1, my b is 6, my c is 9. My discriminant b squared minus 4 times a times c. I get 36 plus negative 36. My discriminant is 0. If my discriminant is 0, that means I have one real solution. And if I were to use this to graph, it means I would have one x-intercept. Since I know I have one real solution, I can't stop here. I have to use the quadratic formula. So we're going to have negative b plus or minus the square root of our discriminant, which is 0, all divided by 2 times a. So we end up with negative 6 plus or minus 0 divided by 2. It doesn't matter if I add or subtract 0. I'm going to end up with negative 6 over 2. My one solution is negative 3. So now we've seen an example of each of the possibilities with the quadratic formula. 2 solutions, 1 solution, no solutions. At this time, what I'd like you to do is go ahead and click on the video link in OneNote. that's titled Quadratic Formula Song. It's on the same page where you found the 9-5 lesson video. Go ahead and take a listen to that song. It might help you with memorizing the quadratic formula. Once you've completed that, then go ahead and try out your progress check using any of the notes that you have in your journal.